is creating an IoT baseball scoreboard with Python. Christian's going to talk about it. Christian.
Thank you. Thank you. Well, first of all, thanks for coming to the talk, everyone. I'm really glad to be here at PyOhio, getting to share a little bit about this project with all of you. Hopefully, for the baseball fans and non-baseball fans alike, there's something that will be interesting here to you. So, this gets on to kind of the goal of my talk. Is just basically I want to go through my project, but it's I don't know. The talk's not just like all about it. It's the idea is hopefully you'll see that even a novice hardware hacker like me was able to put something together that that solved the problem that I had, and hopefully you can take something away from this and be like, well, maybe I'll solve some problem I have with a little bit of hardware and software and some creativity. So that's what I hope to accomplish here with you guys today. So this backstory of this project, I love baseball. It's my favorite sport. It is a super long season though. And as was mentioned in sort of the pre-talk, the games are really long as well. So 2 to 4 hours is not uncommon for a baseball game. There's 162 games in the season, and it spans from April through September, unless your team's lucky enough to make the playoffs, and then you go into October. Anyway, it's a long season. In order to sort of balance my love of baseball with just being like a decent husband and father and not just like pouring everything I have into it. I basically listen to the audio streams or the radio version of the game. I can be doing other stuff around the house or going here and there and listening to the game and sort of keeping tabs on things. But when I'm not like really focused on it, I often lose track, like what's the inning, what's the score, who's up, that sort of thing. So in a baseball park, the scoreboard kind of serves this purpose. So when you go out in the fifth inning to get, some nachos or whatever, or beer, you come back and something happened, you can find out pretty quickly by looking on the scoreboard and see what happened while you were away. So why not have a scoreboard in my house that would serve this purpose? That's what I eventually wound up thinking. So I set out to make a scoreboard. So baseball is like steeped in tradition, right? Like we've got players. We still talk about players like Babe Ruth and Lou Gehrig, Jackie Robinson. It's like what they did matters, and baseball fields, they also have kind of this like tradition, right? Like in the scoreboards or in kind of the architecture, like we still kind of build parks like we used to, and so anyway, I wanted my scoreboard to have this kind of low tech look to it. I wanted to look like a baseball scoreboard. I didn't want like a new LCD kind of display, like, smart assistant kind of thing. Like I want to have scoreboard. The other goal, I want it to be quiet, not disruptive. I don't want like, hey Alexa, what's the score of the game? I don't want something that's like, blah, 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 it's coming back and telling me stuff. And I also want it to kind of just like follow the Unix philosophy of doing one thing and doing it well. So those were like my design decisions when getting into this project. So last year, I made this awesome mock-up of what I wanted the scoreboard to look like. This was actually a coincidence of history. This is when the Indians embarked on their 22-game winning streak, or they had just like won the first few games of that streak last year. For those of you who don't know, the Indians won 22 games in a row last year. It's a really highly improbable and exciting thing for Cleveland Indians fans. Then they lost in the first round of the playoffs to the Yankees, but anyway. So this was the scoreboard. I was gonna use these 7-segment displays to basically represent the runs, hits, and errors, and inning, that sort of thing. And it would give it kind of that retro look that I was going for. The problem was I really was just like jumping into this without knowing how to do a lot of what I needed to do to make this scoreboard happen. So I decided I would kind of scale the project back and tackle something a little less involving fewer of these displays, not having to think as much about power requirements and stuff. But it was real, honestly, like I started into it in last year around August, September, and I just sort of fiddled around with some stuff, and I just learned it enough to know that really I was like it was too much. So I decided to scale the project back even more, and I just wanted to get like my goal at this point was like get a baseball stat that can be represented in 2 digits to show on a single double-digit 7-segment display. So that was my project. I was like, all right, if I can't do that, I can't do anything for this, but let's figure that out first. So I decided to build on the Raspberry Pi Zero W as my platform. The nice thing is it's small, it's quiet, so I can get that kind of like quiet operation thing. It has built-in Wi-Fi, so I can hit APIs to get the data that I need, and full Linux system. I put a Git repo on it, and I can push my code to the Raspberry Pi. It's got some nice features. It's maybe a bit the configuration is a little bit more than you'd have to do for like an Arduino or these cool Adafruit devices now, these Circuit Python devices. Those are like no setup basically. So this one you have to configure the Wi-Fi and the OS and all that, but it's a nice device for these type of projects. Some soldering required depending on what you want to do with it. You can get a version that has header pins like an Arduino has, where you can just like plug in little jumper wires. I wound up getting a cheapo one and soldering my own headers on, which soldering was something that was new to me, but I learned from this project. Last of all, it's not suitable for real-time applications. So if you want to drive like servos or things that are like require precise timing, you may want to consider either as a separate board or something that you interface with from the Raspberry Pi. I'll get into why it matters for my project later, but it doesn't matter that much. For interacting with devices hooked up to your Raspberry Pi, so GPIO, these pins, any pins on the thing, the GPIO stands for General Purpose Input Output, basically pins that you can configure to read data from or write, electrical current or send electrical current through power devices, read data. gpiozero is a library for the Raspberry Pi that lets you interact. It's pretty Pythonic for those of you who are like, kind of want that aesthetic in your code. It's like a nice Pythonic library. So I made use of this one. It's they have functionality for interacting with LEDs all the way through interacting with different like integrated circuits and stuff. I basically just use the LED blinking functionality, and it's pretty nice. So speaking of LEDs, just go over real quickly for those of you who haven't thought deeply or looked into like how to hook these things up. It's useful as a light or a basic 1-bit display. Just something on or off. They're polarized, so you have to have your positive current flowing in through one terminal, negative current throughout the other, or it has to flow through in a certain direction basically. So yeah, that's an LED there. The anode is the positive terminal, cathode is the negative terminal. So with using GPIO0, if you want to just sort of do like the hello world of a hardware project with an LED, this is the code you would need. You import their LED object or class, and you import sleep from time, and you create an instance of this class, and then loop through this while true, turning it on and off with sleeping. And when you do this, the LED will blink. And for me, it was this like super exciting experience. I sort of felt like Tom Hanks, in Castaway, like I've created a blinking LED. I've created fire. So anyway, this is how I felt about blinking that LED when I first got it working. It just seemed like magic. But I don't want to just deal with single LEDs. I have the desire to use these 7-segment displays to represent scores and innings and stuff on my scoreboard. So 7-segment displays, basically these multiple LEDs arranged in a pattern that's useful for representing digits. So they like regular LEDs, they're polarized. So you have these anode pins that you need to send positive current into, and then there are cathode pins that the current flows out through. So I bought a handful of these from Amazon. I was sort of just in this like spree of like, I was excited about this project and I was just like buying parts and stuff and not really paying attention to specifications. And so I wound up getting like this grab bag of parts from Amazon that didn't have a data sheet. And data sheets are like these really useful, for those of you who don't know, they're these really useful technical specifications of whatever parts you're getting, and they tell you like tolerances and like basically how to use the thing. And so I got these displays and didn't really know how to use them. So I fumbled through it, figured it out, but this was a good lesson learned. Like I now consult data sheets before purchasing my parts. So for the scoreboard, I need multiple 7-segment displays, even for the mini version that I want to build eventually. So I was thinking about this, even though I was working on sort of just like, this is the earliest prototype, just work on this little tiny thing, and there will be pictures of it later too. So those of you in the back can see better. But I was thinking about how many, how is this project going to work with the Raspberry Pi? Like I need a certain number of pins to control each segment of the, I need one pin to control each segment of these 7-segment displays, and I'm kind of like pushing near the limit of pins that the Raspberry Pi has available for doing that sort of thing. So I needed to figure out a way to how I'm going to control multiple outputs, many outputs, with only a few output pins on the Pi. So there are better ways to do this, as I've discovered kind of going through this project, but this was this shift register wound up being a kind of the first thing I found is like, how do I like expand the number of outputs on my device with only a limited number of pins. So it's kind of like you take 3 pins from your Raspberry Pi and you can control 8 pins on these shift registers. And a shift register you can think of as like a binary queue or an 8-bit memory chip, basically. So another nice feature of them, you can daisy chain them together, which means you can take the last pin on one of them and hook up another one to it, and the values kind of just like continue to get pushed through to the next one. So I was able to hook up 3 of them, just kind of like one after the other, and you still use the same 3 pins on your Raspberry Pi, and you can hook up many of these in a row to have many outputs. So this is kind of I wanted to have some sort of a diagram to explain how these shift registers work. So there's these 3 pins that I'm not going to get into right now, like how they actually work. But as you're interacting with it in the code, and I'll show you a code snippet in a little bit, but you're basically pushing digits in, or pushing values in. So here I've got these black circles representing a 1, and the white circles representing a 0. So like positive current or negative current. I'm still working on my electronics know-how, so but bear with me. So as you push values in, so there's pushing in a 0 or 0 value there. It shifts. The reason they're called shift registers because the values are shifted over as you add new values into the register. So that's how. So basically, if you wanted to light up, the rightmost circle here, you'd continue pushing in until that value was over where you wanted it. And then I had to add baseballs because it's baseball talk. Whatever. All right. So to interact with these, there was not there was no code in gpiozero for interacting with shift registers, but it turned out they're basically, again, like I said, my project is not much more involved than like blinking LEDs or like flipping pins on and off. And so I wrote a bit of Python code to do that. I created this context manager. So basically, I can. This is sort of the magic of how these shift registers work, where you set this latch pin low, and then you do a bunch of clocking in. It's called of data, and then you set the latch pin high, and then all that data is available to whatever output device you have hooked up to the shift registers. So that's what this method here is all about, is basically setting that latch pin low, then you do whatever you want to do with the shift register object, and then it sets the latch pin high for you at the end. And this is the method for shifting data out. So you basically just give it like a list of 0s and 1s, and it will loop through the data, and it will set the pin high or low depending on if you've given it a 1 or a 0 in that list. And then it does this clock pin off, clock pin on, which is, again, this is like the idea of like clocking data in. It like shifts the state of the register, shifts that data over. So this is an example of how you use it. So you just create an instance of the class, and you pass it. These are pins. Those are those gpiozero LED objects up here, basically. They're just representing pins that are hooked up to my board. And then just say with sr.latch, and then you shift out whatever data, and that would basically enable or disable those pins on the shift registers. In this case, it would be a single 8-bit shift register because I have 8 values in there. And then the way I do digits is basically I just have like a dictionary where I map. If I want to show the number 3, that's a certain pattern of bits that happen to correspond to the right segments on my 7-segment display to show the number 3. So yeah, that's how that works. So here's a very early prototype hooked up to an Arduino. The thing with the displays that I have is it's easy to set, like to show a number. Like for instance, I have the number 8 showing on here on this example. The problem is it's hard to show anything more. Like showing the number 10, for example, is not possible just by like having all of your like positive and negative. You have your cathodes connected to power, and then you send in like 8 bits of data. You can't show 2 digits with only 8 bits of data, because that's like basically you only have pins to set 8 of the segments effectively. So there, I have to be able to well, first of all, the other thing is I can't like I can't switch on and off the cathode pins, like those negative pins. The Raspberry Pi can only handle a certain amount of current through its GPIO pins, and if I was to send all of the current that was flowing into the LEDs through a single pin, it would burn out the Raspberry Pi. So there's this great device that all of us depend on in so many ways that's all baked into our CPUs everywhere. Transistors, which in my case work as nice electronic switches. So I was able to work around basically being able to turn the left and right digits on and off using a transistor, put kind of in that behind that cathode pin of the of these 7-segment displays. So the nice thing that this lets me do when I can control, like turn off the left and the right digit, is there's this effect called persistence of vision, where if you change things fast enough, like if I move my hand up and down fast enough like this, like you see sort of like a blur of my hand. Is my hand up or down? It's like your eye kind of like keeps that. I don't know. It like stretches things out. So if you blink LEDs on and off fast enough, you can do this with like 2 LEDs, and if you are like quickly turn them on and off, it'll appear that they're both on at the same time. So this will work for me with my 7-segment displays as well. If I blink 7 and 8 on and off quickly enough, I'm doing this right now. I'm just like pow, 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 pow. No, I'm really not. But if I was doing that, it would appear that 78 was being shown when in fact only at a single moment in time, only a single digit is being lit up. So the transistors let me turn those on and off very quickly, and in between turning them on and off, I can clock in different bits into the shift registers, which let me show different digits, and that's how I can go ahead and show 2 distinct digits, even though I only have enough inputs into the displays to show 1 digit. So an interlude here. I needed to learn how to solder for this project because, as you saw on a previous slide, this was not going to work very well to make anything that looks like a scoreboard. It looks more like, I don't know, a mad scientist bomb in a movie or something. Actually, that's another thing that 7-segment displays are really useful for, right? Like in the movie, they always have a 7-segment display showing the countdown. So anyway, I got this really advanced kit on learning how to solder. And it came with a board and some components and some instructions and some wires, and I just kind of worked through it, did some really terrible solder joints, but along the way learned some lessons, and I still use the junky little soldering iron that came with it too. So I suggest if you're going to get into these kind of projects, just get a kit like this and play around with it. It'll have you solder a bunch of like dummy wires that don't do anything, but you'll learn stuff along the way. So after learning all this stuff that I just explained over weeks and months in the cold winter of Ohio, I started with this kind of tangled up prototype on the left, and I started taking those things, basically wiring it up on and laying it out on a circuit board the way I wanted it, putting the different components together, and I came up with what you see on the right here on the screen, which was a single, and I've got it here if anyone wants to come and check it out afterwards, just a single little board with a 7-segment display that I could show numbers on, and that was a big deal for me. And so here's a little video that I have of me doing this. This was sitting in my house getting this to work via the Python interactive interpreter. So yeah, so right now it's like only a single one of these digits is actually lit up at a time, but the camera's low enough frame rate that it also is tricked by that persistence of vision. So yeah, phase 0 was complete. I'd figured something out, and I felt pretty good about that. So it was time to move on to the next phase of actually building. So, and I should back up. So the beginning, like I wanted this scoreboard to be like as big as that whiteboard over there, like a wall-sized like thing, sort of like an artwork piece in my house that I like hang on the wall and like. So anyway, I really had to dial my ambitions way back. So you'll see that, or you have seen that. You'll continue to see that. So I moved on, though. I needed to have a multi-display prototype. So again, we're back to sort of like mad scientists, like wires everywhere, really finicky sort of thing. But I was at least like learning how I was going to wire all this stuff up in the end. And I definitely recommend using these solderless breadboards at this phase. Like it was really good to make some mistakes on this before I soldered stuff and spent time and frustrated myself more. One thing, I observed some weird electrical characteristics. There are, and I don't fully understand it. I think it has something to do with the length of the wire and the rate at which I was doing these, like flipping these digits back and forth. There was weird interference, and it messed with the internal state of the shift registers. So when certain numbers were shown on the display, like the other half of it would like light up in weird ways. So yeah, there's when I shortened my wires, the problem went away. I think there are actually correct ways of solving that, which I have not done. I think they involve capacitors or something. But in any event, so that's a lot about the hardware. I'll just talk a bit about the software here because we're at a Python conference, and here I am just like nerding out about hardware. In order to show any data on this display that I have with 3 digits, one for each team's runs and then another for the inning, I need to be constantly updating the display, as I mentioned, because otherwise, I'm only going to be showing 1 digit or so. It's going to be this sort of like herky-jerky thing if I can't like be constantly driving that thing to show data on both sides of the display. I also need to be periodically fetching game data from the MLB API. So I made use of these 3 Python standard library modules to do this. Here's a question. Who's used the sched module before? Anybody? Okay. We've got one taker back there. All right. So it was interesting to me. I was like, looking at the standard library for what I would use for this. The sched module was created 28 years ago. It was like part of the initial version of Python checked in by Guido. So anyway, it has some. It's useful for what it does, which is lets you schedule things based on time, which is what I wanted to do. So anyway, threading and queue are useful for when you're doing multi-threading, and I made use of them. So here's a kind of a high-level diagram of the project. So on the right here, I have a thread that is running the display, and it's just constantly running to show whatever data has been last sent to it through this queue. So this is like always running, always running. Anyone who's done UI work, it's like your UI event loop or your just like your UI render thread, that sort of thing. And then over here, I have the sched module, which you can kind of picture as that clock of the internet. And then this thread just periodically is doing something. So the way the scoreboard works is when it powers on, it checks to see what the game schedule is. If there's any games later in the day, it schedules to start tracking that game at that time, and then it reschedules itself for 8 a.m. the next morning to check the schedule again, and it just will repeat through that. And when a game starts, it also then begins like this more a shorter interval polling of data for the game. So this is a high level just of how the whole thing works. 2 threads, not super complicated. The queue makes it nice for communicating between them. Actually getting the data for the games, I use this MLBGame library. It's open source. I committed at least 1 bug fix to the project. It's interesting. It's like active during baseball season. Like in the off season, people aren't really doing much with it, aren't really working on it. But as soon as like spring training approaches, like you see people committing stuff, and the maintainers get a little bit more interested in accepting pull requests and stuff. So yeah, it's useful. It's not the greatest API, but it works, and I didn't have to write all this code because the MLB API is all XML, and it's not something I wanted to like try to figure out on my own. I had enough to do. So spring training, this is when baseball teams are like getting ready to play on the field. People are getting excited about baseball, and I was madly working on this project because I wanted to be ready in time for opening day. It was like my own goal was like, you know, get the project ready for opening day, just like the teams are working on getting ready. So I started, I had my prototype, mad scientist style, and I wanted to get it into something I could put behind a scoreboard. So I started working on actually making this display. So yeah, worked on more soldering. The previous picture showed the layout of my the back of the board where I'd have basically the cathodes all hooked up, and those wire up to the transistors, which you can see right here. So this is like the back side, this is the front side. Bunch of resistors at the top. Maybe I didn't need that many, but it made some things easier, I think. So here it is. Another thing I would recommend is you do these projects as you do them kind of modularly. So you can see here I've got this module down there hooked up to the mess of breadboard wires and stuff like that. So I was able to test, okay, at least I've got this part working right here. Kind of like, you know, as you're coding, like you test like certain parts of your code, unit tests or whatever. It's good to do that with hardware too. So then I started working on the shift register portion here, which would actually replace all that tangle of wires up there with that smaller tangle of wires. There's the final board. It actually wound up, you know, I connected the two when I knew they both worked. So you've got the shift registers hooked up to the display board there. And then this was my cereal box cardboard cutout mock-up of what I wanted my actual like scoreboard facade to look like. Just wanted to like have something to see before I started cutting wood or doing whatever I wound up doing. All right, so opening day. I wasn't totally ready. The scoreboard worked, it displayed stuff, but I didn't have the actual, like I had that cardboard is basically what I had. It didn't actually look like a scoreboard. But on the very first pitch of the very first game of opening day, it was like the Cubs versus the Cardinals, I don't remember. But I do remember the very first pitch, the player leading off the season hit a home run, and my scoreboard picked it up, and I was sitting there at my desk, and I was like, just like it was such a great moment. It was better than like blinking that LED. I was happier than Tom Hanks on Castaway. So that was opening day. Then later that day, the Cleveland Indians played, and they won their game 8-4, and the scoreboard tracked the whole game, and I listened to the game and had the scoreboard tracking it, and again, I was just like so pumped. So yeah. So I then, you know, in the next couple days after opening day, I tried to make it actually look like a scoreboard, and if I can pull it up here now that I've talked about it all this time, if I don't unplug something, here it is. So this is the tiny version of the scoreboard. This is tracking, it's still showing it. So that's the, what did we say, the Blue Jays and somebody else playing right now. Blue Jays and White Sox. So there they are. They're in the 9th inning. Is it still on, or did it like? All right, so this is it. This is the final prototype. Again, I still want to make this like wall size thing, but this is what I've got right now, and it's been kind of cool. I've had it in the kitchen at home, and have it on during games, and the kids will walk through and be like, "Dad, did you see the scoreboard on the game? You know, the Indians are winning," or "Oh, look at how terrible they're losing today." And it's just like it's been this thing that, you know, it's my love of baseball that like made me create this thing. But now my family is kind of like, you know, I don't know, it makes it more accessible to everyone. So yeah, it was kind of cool. So just like kind of closing tips on if you want to take on a project like this, and some of these are things that you probably know from work and stuff I should have known, and maybe, you know, have played into this a bit, but, you know, start small with your projects. Your big vision, what you want to build, like whittle it down to something really, you know, really achievable to start with, and you'll learn a bunch from that, and you'll make some mistakes there, and maybe make them on a smaller scale than if you just like dove right in. Let's, you know, use loose coupling both in your hardware and your software, because if you know, fry something when you're soldering, or, you know, that you wired up incorrectly when you were soldering, you know, you can replace it hopefully without a lot of extra time, and do it with your software too. It's nice for, there were a couple times when I was working on this in my basement. It was super cold down there in like the 0-degree section of winter that we had, or, you know, below in the teens. And And so I had some stuff mocked out, and I was able to work on the code on my laptop away from the hardware in the basement, which was nice. Try to have a project bench somewhere you can tuck away this stuff and come back to it when you have only an hour to work on it, and you don't have to like set everything up and tear it all down. And then learn a bit about how electricity and electronics work. I've tried to do that. I got a book and stuff, and yeah, it helped to at least, you know, struggle with that stuff in my mind. So that's all I've got. Here's some contact info if you want to find out more about the project or talk to me about it. I've got some code on GitHub as well. It's not super useful to put to folks unless they build something like this, but I'm happy to help anyone build one. I should probably put some instructions on how to do that. Yeah, that's all I've got. Thanks so much for coming and taking the time to listen.